Okay, let's look at first principle. In our previous class, we were able to define differentiation. We said this is a mathematical approach used in finding the slope of a function without plotting the graph. Then we focus our attention on the first method of differentiation, which is called the general method of differentiation. So in this class, we shall be looking at first principle. Okay, now in first principle, two things are noted. Two things should be noted. The first is that there must be an increase in x and y. Increase in what? In x and y. You have to assume an increase in x and y. An increase in x, increase in x implies x plus delta x. Delta x is not same as the x. Okay, just take notes. Then the second one is increase in y. Increase in y will give us y plus delta y. This is the first thing you must have to take note of in first principle. To take note of is taking your limits. In taking your limits, the limit of a function is, for first principle, is when delta x is approaching 0, delta y over delta y over delta x will approach the y dx. What I'm trying to say, when you use the first condition for first principle, okay, this condition is used to start up the game, to start up the process of differentiating with first principle. Then at the end part of the differentiation, we have to take what we call limits. And limit of a function of a function in first principle is as delta x is approaching 0, the delta y over delta x is approaching the y dx. Now let's see a practical example. Okay, let's look at this example. Given that y equals 2x squared, and let's say find the y dx using first principle. Now we have noted the two conditions that are necessary for you to actually differentiate using first principle. The first condition we said is that there must be an increase in x and increase in y. And so increase in x means x plus delta what? X. Y increase in y means y plus delta y. This implies that anywhere we say x, we substitute the value of x with what? With x plus delta x. Y that of y with what? Y plus delta y. Now let's start the process. For this, our solution becomes, so we say let there be an increase. Let there be increase in x and what? And y. Increase in x and y. Increase in y implies y plus delta y. Here I'm replacing my y with what? Increase in y. Then equals to 2 in brackets, our x becomes what? X plus delta x. Here we have our square. Alright? Okay. So this will give us y plus delta y equals 2 in brackets. By the time we expand this function, this will give us x squared plus 2x delta x, 2x delta x plus delta x squared, all in bracket. Then I'm going to expand this by multiplying all of this function by 2. This will give us y plus delta y equals 2x squared plus 2 times 2x will give us 4x delta x, y 2 times delta x squared will give us 2 delta x squared. Okay, and our aim is to find the y dx, and I will say that in the second condition of first principle, as delta x is approaching 0, delta y over delta x is approaching the y dx, right? That means that anytime delta x becomes 0, this becomes what? The y dx. So It simply means that for me to generate delta y over delta x on the left hand side, I have to move this y across the other side. This will give us delta y equals 2x squared plus 4x delta x plus 2 delta what? X squared minus y. Then we're going to have delta y equals 2x squared plus 4x delta x plus 2 delta x squared minus our y. The value of y here is 2x squared. So I'll put the value of y as 2x squared. Now if you notice, we have minus 2x squared, we have plus 2x squared. So 2x squared minus 2x squared is 0. So these two will cancel out, right? So remaining delta y equals 4x delta x plus 2 delta x squared. Alright, so when we get to this point, we have delta y, then will give us 4x delta x plus 2 delta x squared. Okay, we are almost getting to the end of the game. Now, the next thing we need to do here is to divide both sides by delta x, because our aim is to generate delta y over delta x. So I will say divide through by delta x. This will give us delta y over delta x is equals to 4x delta x over delta x plus 2 delta x squared over delta x. So this will go with this. One of this will cancel one of these. So we have what? Delta y over delta x equals 4x plus 2 delta x. Then this is when the second condition will now come in. We take our limit of function. Limit when delta x is approaching 0, we say that delta y over delta x will approach the y, the what? The x. So what does that imply? It means that when delta x becomes 0 here, this becomes what? The y, the x. Therefore, this becomes the y, the x is equals to 4x plus 2 times 0. Right? So answer becomes what? 4x. Therefore, the y, the x is 4x. If you look at this using general method, when you multiply the power by 2, we have 4. Subtract 1, we have 4x. So here becomes 4x raised power 1, which is the same as what? As 4x. Y equals ms plus c. Let's see example 2. Y equals ms plus c. Find the y, the x using first principle. Y equals ms plus c is the general form of a linear function. We all know, right, that the general form of a linear function is y equals ms plus c, where y is called the dependent variable. Y is called dependent variable. S is called independent variable. M is our slope, which is our dy dx. Then C is called the intercept. In our next class, when we talk about geometry, coordination, or coordinate geometry, I'm going to explain, give more insights on y equals ms plus c as a function. Okay, so just take note that all linear function, the general form is what? Y equals ms plus c. Linear functions are those functions that have the highest power of 1 as their exponents. So the highest power of x here is what? Is 1. Y is 1. So this is called a linear function. So a graph of y against x will give us a straight line graph of this form. a straight line graph of this form, where we have C and our slope, which is our dy dx, is going to give us, we're going to have n. Is our slope changing y over changing s equals what? N. So if we differentiate this, we are expected to have n as our final answer, right? Good. All right, so let's look at this. Okay, before we differentiate this, if we are given y equals 2s plus 4, for instance, and there's a find slope. Find slope, this also means find what? Dy dx. What do we do to find slope? We just have to compare the equation given with the general form, which is y equals ms plus c. Since all linear form has a form of this function, right? So when you compare m with this function, that means our m is was 2. When you compare the general form rather with y equals 2s plus 4, by comparison, mx is equals to 2x. So s will go with x, therefore our n is 2. So the slope here is 2, while our intercept is what? Is 4. Our slope is 2, while the intercept is what? Is 4. Alright, so let's differentiate this using first principle. The first condition says increase, right? Increment or increase in what? In x and y. We have seen that increase in x implies x plus delta x, while increase in y implies y plus delta y. So this will give us y plus delta y, all equals to m in brackets s plus delta x plus c. So by the time we solve, we have y plus delta y equals m times s will give us mx, and we expand this, plus m times delta s will give us m delta x, then plus c. Okay, so we have to move this y across to the other side. This will give us equals ms plus m delta s plus c minus y. Therefore, delta y equals mx plus m delta x plus c minus the value of y here is what? ms plus c. So we're going to have delta y equals ms plus m delta x plus c minus ms minus c. So this will go with this because ms minus ms will cancel, y plus c will go with minus c, c minus c will cancel. So we are left with delta y equals m delta x. Alright? Okay. So what we do next, we are going to divide through or divide both sides. Divide both sides by delta x. This will give us delta y over delta x equals m delta x over delta x. So this will cancel, therefore we have delta y over delta x equals to m. Then we take our limit of function that says that as delta x is approaching 0, delta y over delta x is approaching dy dx. Therefore, our dy dx becomes what? M. Okay, because from here, if you look at this, we have delta y over delta s equals to what? M. So I'm still going to apply the second condition that as delta s is approaching 0, delta y over delta s will approach the y ds. Okay, let's see other examples on first principle. Okay, let's look at this question we have here. We have to find the y ds when y equals 1 over s squared using first principle. Now, for us to differentiate using first principle, we already know the conditions. Okay, that the first condition says that we have to assume increase in y and increase in x, right? Okay, solution to this is that increase in y is our y plus delta y, which is equals to 1 divided by s plus delta x all squared. Alright, so by the time we expand this will give us y plus delta y equals 1 divided by s squared plus 2x delta x plus delta s squared. 1 divided by this. The whole of this is equals to this. By expansion, we're going to have this. So we have to take our y to the other side of the equation. Here becomes, okay, delta y equals 1 divided by s squared plus 2s delta x plus delta s squared minus y. So this is also same as delta y equals 1 divided by s squared plus 2x delta x plus delta s squared minus the value of y is what? 1 over s squared. Alright, so when we achieve this, we are going to collect our like terms. Our like terms is going to square. That will give us s squared. Sorry, if you divide the whole of this with this, alright, this we cancel this, we are left with s squared. Then s squared times 1 will give us s squared. Then we have minus, when we divide the whole of this by s squared, alright, s squared will cancel s squared, then we are left with this. Then this times minus 1, that will give us minus, right, in brackets. This will give us s squared plus 2x delta x plus delta s all squared. Okay, then this will give us delta y equals s squared minus s squared plus, minus 2x delta x minus delta s squared. Alright, all divided by s squared plus 2x delta x plus delta s squared multiplied by s squared. So this, we cancel this, we go with this, we are left with minus 2x delta s minus delta s squared divided by this. Then I will say divide both sides by delta x. Divide both sides by delta x. So we're going to have delta y over delta x equals minus 2x delta x minus delta s squared divided by our numerator, which is s squared plus 2x delta x plus delta s squared, alright, all multiplied by s squared, then divided by delta x. Okay, so we divided both sides by what? Delta x. So we have divided by delta x here. So this is same as, if I remove this sign of division and put times, we are aware that here becomes 1 over delta x. So 1 over delta x, we multiply this, right? That means delta x, we cancel delta x from here. This, we cancel one of these. This also, we also cancel one of these. So we are left with delta y over delta x, which is equals to minus 2x minus delta x divided by s squared plus 2x delta s plus delta s squared, all multiplied by s squared. So when we get to this point, for we to solve further, we have to take our limit of function. The limit of function, we take our limits as delta x is approaching 0 delta y over delta x, we approach dy dx. So this implies what? Therefore, our dy dx becomes, so it simply means that anywhere we see delta x, we're going to put 0. So here becomes minus 2x minus 0 divided by x squared plus 2x times 0 plus 0 squared, all multiplied by x squared. So divide dx becomes minus 2x divided by 2x times 0 is 0, 0 squared. Okay, we have 0 squared here. This and this is off. We are left with x squared times x squared, and that will give us x raised to the power 4. This is same as one of these s, we cancel one of these s from here. We're going to have minus 2 divided by x raised to the power of 3. This is our final answer. We can as well say this is same as minus 2x raised to the power of what? Minus 3. Alright? We can leave our answer in this form. This is our answer. Alright.